Imagine a planet almost the exact same size as Earth. Same rocky core, same age, born in the same swirling disk of gas and dust billions of years ago, just a little closer to the sun. Now imagine that planet turned into a literal hell. Temperatures hot enough to melt lead. Atmospheric pressure 93 times greater than what you feel standing at sea level on Earth. Clouds made of sulfuric acid raining endlessly, but so hot that the rain evaporates before it ever hits the ground. That planet is Venus, Earth's closest neighbor, our cosmic twin, and it is completely, utterly dead. Venus has been mesmerizing humans for thousands of years. It's the third brightest object in the entire sky, outshone only by the sun and the moon. Ancient Romans named it after their goddess of love and beauty. Ancient Greeks called it Aphrodite. It's the only planet in our solar system named after a female deity. And from a distance, Venus is gorgeous, a brilliant, creamy white orb blazing in the twilight sky. Depending on its position in its orbit, you can spot it as the evening star just after sunset, or the morning star just before dawn. In rare cases, like what happened in March 2025, Venus can actually appear in both the morning and evening skies on the same day, a spectacle that won't repeat until 2033. But point a telescope at it, and you'll notice something strange. Unlike Mars or Jupiter, you can see a surface. Venus is permanently, completely wrapped in dense clouds, a thick, unbroken blanket stretching across the entire planet. Scientists call it the most reflective surface in the solar system. Those clouds bounce back about 70% of all sunlight that reaches them. So for most of human history, Venus was a mystery, a beautiful, gleaming sphere that revealed nothing about what lay beneath. What we eventually discovered was worse than anyone imagined. On paper, Venus and Earth should be nearly identical. Venus has a mean radius of about 3,761 miles. Earth's is 3,959 miles. That's a difference of less than 5%. They have similar mass, similar internal structure, rocky crust, mantle, iron core. They formed around the same time, roughly 4.5 billion years ago, from the same region of the early solar system. Scientists even believe that billions of years ago, both planets may have had liquid water on their surfaces. Early Venus, some models suggest, could have been remarkably Earth-like, perhaps even home to shallow oceans for as long as 2 to 3 billion years. So what went wrong? The answer is a runaway greenhouse effect. And it's one of the most terrifying cautionary tales in all of planetary science. Venus receives about 91% more solar energy than Earth does. As the young planet warmed, its oceans began to evaporate. Water vapor is itself a greenhouse gas. More vapor meant more warming. More warming meant more evaporation. The cycle fed itself, faster and faster, until there were no oceans left. Then the water vapor was broken apart by ultraviolet radiation, and the hydrogen escaped into space. What remained was a thick atmosphere dominated by carbon dioxide. Today, about 96.5% CO2, with the rest being mostly nitrogen and trace gases. That atmosphere acts like a suffocating blanket, trapping solar heat with ruthless efficiency. The result? A surface temperature that averages around 465 degrees Celsius, roughly 870 degrees Fahrenheit. Day or night, poles or equator, it doesn't matter. Venus is uniformly, relentlessly hot. If you stepped onto the surface of Venus, ignoring the fact that the pressure alone would crush you like a tin can, you'd be standing on a vast volcanic plain. About 80% of Venus' surface is covered in smooth volcanic terrain, with two major highland regions, Ishtar Terra in the north, roughly the size of Australia, and the larger Aphrodite Terra near the equator, approximately the size of South America. There are mountains, there are volcanoes. In fact, recent evidence from 2024 confirmed active lava flows on Venus. on a shield volcano called Sif Mons, and on a flat plain called Niobe Planitia. Venus is geologically alive, even if nothing else is. But here is where things get genuinely strange. About 31 miles above the surface, safely above the hellish ground, temperatures drop to somewhere between 86 and 158 degrees Fahrenheit. Atmospheric pressure at that altitude is similar to what we experience on Earth's surface. And up in those clouds, scientists have noticed something odd. Persistent dark streaks appear at the cloud tops, absorbing ultraviolet radiation and stubbornly resisting the 224-mile-per-hour winds that whip around the planet. Nobody has been able to fully explain them. Some researchers speculate they could be fine particles, ice crystals, or iron chloride compounds. Others, and this is the wild card, suggest these streaks could potentially be microbial life of some kind. Life adapted to floating in the Venusian cloud layer, protected from sulfuric acid by ring-shaped sulfur compounds. This is a minority scientific view, but it has not been ruled out. Venus has another deeply bizarre quirk. It spins the wrong way. Almost every planet in the solar system rotates in the same direction, counterclockwise when viewed from above the solar system's north pole. Venus rotates clockwise, and it does so with extraordinary slowness. One full rotation on its axis takes about 243 Earth days. Meanwhile, a full orbit around the Sun takes only 225 Earth days. That means, on Venus, a day is longer than a year. If you somehow survive long enough on Venus's surface to watch the sky, you would see the Sun rise in the west and set in the east, moving backwards across the sky, incredibly slowly. Scientists still are not sure exactly how Venus ended up rotating this way. Some think a massive collision billions of years ago flipped the planet. Others point to complex gravitational interactions with the Sun and its own atmosphere as a possible cause. Venus also has no moon. Unlike Earth, whose moon stabilizes our axial tilt, drives ocean tides, and may have played a key role in making our planet habitable. Venus spins alone with no such gravitational companion. We did not send robots to Venus simply out of curiosity. For a brief, optimistic moment in the early space age, scientists genuinely wondered if Venus might harbor life beneath those clouds. The Soviet Union was especially determined to find out. Their Venera program launched more than a dozen spacecraft toward Venus between the 1960s and the 1980s. Venera 7, in 1970, became the first spacecraft to successfully transmit data from the surface of another planet. What it sent back was not encouraging. Extreme temperatures, crushing pressure, and a surface that looked like baked volcanic rock. Several later Venera probes managed to land and survive long enough, barely, to photograph the surface before being destroyed by the heat and pressure. The longest surviving lander lasted about 127 minutes. NASA's Magellan spacecraft, which operated from 1990 to 1994, mapped about 98% of Venus's surface using radar, giving us our most complete picture of the terrain. And Japan's Akatsuki probe orbited Venus from 2015 to 2024, studying weather patterns and searching for signs of volcanic activity. As of 2025, there are no active spacecraft at Venus, but that is about to change. NASA has approved 2 major missions, Da Vinci, which will send a probe diving through the atmosphere to study its chemistry, and Veritas, which will map the surface from orbit using advanced radar. The European Space Agency's Envision mission is also in development. All 3 are targeting launch dates in the early 2030s. Additionally, a private mission called Venus Lifefinder, developed by MIT and the rocket company Rocket Lab, is targeting a launch no earlier than 2026, the first private interplanetary spacecraft. So why does any of this matter? Venus matters because it is us, or rather, it's what we could become. Planetary scientists describe Venus as an anchor point for understanding habitability. Earth is the only world we know for certain can support abundant life. But studied in isolation, we don't know where Earth's boundaries are. What conditions are absolutely necessary? What tipped the balance? Venus gives us a comparison. Two planets, almost identical in size and composition, that ended up on completely opposite paths. One became a living world, the other became an inferno. The difference came down to orbital distance, solar energy, the presence or absence of a moon, and the catastrophic feedback loop of a runaway greenhouse effect. Understanding Venus helps us understand what makes a planet livable. And as we discover thousands of exoplanets orbiting distant stars, many of them in or near the so-called habitable zone, Venus reminds us that proximity to the right zone is not enough. The details matter, the history matters, the feedback loops matter. In a strange way, Venus, this dead, crushing, scorching world, is one of the most important planets in the universe for answering the question we care about most. Are we alone? Venus is the brightest star-like object most of us will ever see with our naked eyes. It is beautiful, close, and in some ways comfortingly familiar. But beneath that gleaming surface lies a warning. Planets can die. Climates can spiral beyond the point of no return. The same forces that make a world warm and hospitable can, under the wrong conditions, turn it into something that would kill you in seconds. The next time you spot that brilliant white dot blazing in the western sky after sunset, that is Venus, Earth's dead twin, a mirror showing us one possible future. Look carefully.